This is Ethan Von On and Holden Thomas, and this is our CS2316 final project. So, for the purpose of our project, we wanted to examine to what extent the success of a college and its football team are intertwined. We're going to define the success of a football team by its record and the net revenue that it brings in for the school per student compared to the net investment by school per student. And we're going to use the application number for a school as a metric to determine the school's relative success. So we chose this topic because we're both interested in sports, and football programs represent a huge expense for many universities, of 10 times exceeding over $100 million. So as college students, we're interested to see if this money that we pay in athletic fees is creating an impact on the growth of the school's enrollment and funds for the school. And our hypothesis is that as schools spend more money on their football program, its football program will see greater successes, which in turn will lead to more generated revenue for the school and a growth in the school's application number. We expect to see outliers as a greater investment alone cannot guarantee successes on the field. So for our data collection, our downloaded data set, the CSV one, we retrieved from the U.S. Department of Education, and it contains data regarding the number of students in each school, as well as the tuition prices so we can find how much they're spending per student. Our JSON, we accessed the College Football API, which contained data regarding the wins and losses for each school over the past 10 years. Our HTML, which we used Beautiful Soup on, was a website that contained the admission rates for each school over the past 10 years. And then our additional data set was a downloaded CSV from Knight Newhouse database that contained data on how much each school spends on its football program and how much revenue the school receives.
Our first source was the CSV. To clean the CSV, we first read it into a pandas data frame and just index out the relevant columns we were looking at, mainly the school's name, what state it was in, its tuition fees, and then the undergrad enrollment. Then we indexed out for public schools over 12,300 students in states where Power 5 schools were, since we were looking only at Power 5 public schools. This reduced the list of schools from 6,400 to about 350. And then we manually went through a process of picking a specific state, picking out the Power 5 schools from that, removing all other schools to get out all the remaining schools that we needed. We then returned that to a CSV. Next was the JSON file, which was the API. We created a list of the years we were looking at, the team names, and then the school names. Then we checked each team name and updated it to match the formatting that the API uses for the links. Then we iterate through each year, making requests for the specific team and year, and then that converted into a JSON. We then went to the first dictionary in the list of dictionaries, got out the number of wins, losses, and whether the team won at least 6 games. We then added this to a list and created a list of lists. And then this was converted into a pandas data frame.
To clean our HTML data set, we used Beautiful Soup to parse through the HTML, which includes using the .find and .findAll methods. I then created a list of endpoints for each individual school and iterated through this list, finding the admission rates for each school over the past 10 years and added this to a data frame. These values contained a percent sign, so I then used slicing to remove the percent sign so that we could cast these values to a float and then compare them. And then we wrote the data frame to a CSV file.
Finally, for our additional CSV, we read it in as a pandas data frame and then iterated through each column and remove the $signs, trailing spaces, and commas from each column by splitting it and then rejoining them. And then we removed the schools that we were not going to be looking at for our analysis. For our first insight, we created a net profit column by subtracting the total revenue from the total expenses. Then we created a column for football spending as a percentage of the university's total spending by dividing the total football spending by the total academic spending. Then we grouped by the win numbers with these new columns we created. We did linear regression and found correlation coefficients on these. And what we saw was the correlation coefficient between the number of wins and the percentage that a school spends on football is a 0.917, suggesting that there's a strong positive relationship between these two. Additionally, the correlation coefficient between the number of wins and net profit was 0.749, which suggests that there is also a positive relationship between the amount of wins and the amount of money a school gets. Additionally, the correlation coefficient between number of wins and spending was 0.926. And from the linear regression, we found that for every $1.6 million of spending, this will help result in one additional win, and each additional win is going to bring in an additional $810,000 in profits. For our second insight, we made spending per student columns by dividing the football spending by the undergraduate enrollment. We also made a net spending by subtracting revenue and spending columns and then dividing this by the undergraduate enrollment. We then sorted this by spending per student and found the mean to be $1,741 of spending per student with $51 in profit. And we made visualizations to show each school's spending and net earnings. And what this demonstrates is that football spending accounts for a large amount of spending on a per student basis and is a significant portion of any university spending. For our third insight, we found the change in ticket sales and donor spending from each year's, and we used 2014 as our base year. And then we removed we only looked at years 2015 and 2019. We did this because COVID had significant impacts on both funding and how many games were played, so it was inconsistent with the rest of the season. Then we grouped by the number of wins and the average change in ticket sales and donations. We found the correlation coefficient between the number of wins and the change in ticket sales and donations. We then also grouped by bowl game appearances and found average donor contributions and ticket sales. So we saw that for both the number of wins and the change in ticket sales and the number of wins and the change in donations was a positive correlation. Additionally, we saw teams that were able to make bowl game appearances had 35% higher donor contributions and 27% higher ticket sales than teams that were unable to make it to a bowl game.
So for our next insight, we wanted to look at if a school's football record influences how many people want to attend the school. To do this, we merged our API dataset, which contained the team's records, with the dataset that contained the admission rates for each school. I then performed a group by and found the total number of wins for each school over the past 10 years and the average admission rate associated with each school. I then returned a data frame containing the total number of wins for each school compared to their average admission rate. And to show this, I plotted this histogram comparing the total number of wins versus the admission rate. We thought that the more wins a football team gets would lead to more people wanting to attend the school and hence a lower admission rate. So the lower admission rate should have the largest number of wins. However, the histogram shows that this is not the case, as the schools with the largest number of wins have an admission rate between 70 and 80%. Thus, the two are not necessarily correlated, so a football team's record doesn't necessarily influence how many people attend the school. For our next insight, we wanted to look at if the amount of money a school spends on their football team impacts how many games that they win. To do this, I merged our API dataset, which contained the team's records, with the dataset that contained the total spending for each school. I then found a win rate column for each school, and I did this by taking the number of wins over the total number of games times 100 to make it the rate. I then returned the data frame containing the average win rate for each school and the average amount spent for each school. And to show this trend, I plotted a scatter plot showing the total football spending versus the win rate. And the scatter plot shows that the total spending can help to predict a team's win rate, as most of the teams who had a high win rate spent the most amount of money on their team. In general, the higher the win rate, the more money spent on their football team, but there are a couple of outliers of teams that spend a lot and were near the middle of the pack in win rate.
Overall, we found that as a school spends more money on its team, the team sees greater success on the field. This success leads to more generated revenue for the school, but doesn't impact the school's applications numbers. Thus, the success of a college and its football team are partially intertwined, not completely, since it doesn't influence the admission rate of a school. This suggests that addressing a adequate amount of resources to the football program will provide positive outcomes for the school. The challenges that we had during the course of this project was finding sources that met the requirements outlined for the project that also connected with our data sources. And during the project, we also learned how to use the Skippy Stats module.